record. Ready? Now share screen. Okay. You see this problem is from the 2005 test, right? And 2007 test is a calculator allowed problem, and pretty much is the same as the other ones. You don't have the position. You see the graph here. This graph is the velocity of the particle with the time, correct? You see? So you see that this is the time. The last root is square root of 5 pi, begins in 0. It goes from 1, you see, to -1, right? And here is explicit. The function is vt equals sine t squared, correct? And the initial position at t equals 0 is 5. So it's in the number 5 in the number line, correct?
Yeah. El C
So
es 5.
everybody, let's read the graph first. So here the velocity is positive, so the particle is moving to the
Right.
To the right, correct? Now, here the velocity is increasing. Here the acceleration, because this is the slope of the tangent line here, is positive. Reach a maximum of 1, and then the acceleration becomes negative, and then begins to stop the particle. Once the particle stops, begins to move to the left, right? The acceleration is negative, negative, then 0, change sign, and then begins to stop the particle, and then stops the particle, and then begins to move the particle to the right. You see, it's a periodic movement, back and forth. Everybody catch that? It's very important you learn to read these graphs because it gives you understanding of what you have to answer. Okay. Acceleration. Find the acceleration of the particle at time t equals 3. So, what to do? Very simple. Yes. You have to take the derivative of
Sine t squared.
Sine t squared. Even you don't have you have a calculator, you can do this pretty much by hand and then put in the calculator. But with a calculator, you can do this, correct? Okay. So let me see. Where is the calculator? Okay. Let me just right here. Let me just put the calculator. Remember that you have to write something. You have to write the acceleration is the derivative of the velocity respect the time. Then you want acceleration in parentheses 3 is derivative of the velocity respect the time evaluated in t equals 3. Okay, so that is something that the reader wants to see, correct? So okay, well, let me see. Let me just stop share. Okay, this is what you see. This is the first part of the problem. So remember, you have to put on your paper the equation you are going to use. A equals dv dt A3 D3. So obviously, V of t is the sine of t squared, correct? So you don't have to put this one right here. If you have this one at the top, you have just to put this one. And with the calculator, correct? With the calculator, yeah. Let me just share the screen again. Share screen, calculator. With the calculator, you add a calculating page, and then you put menu, calculus, derivative at a point, variable x, value is going to be 3. And then you put, okay, first derivative, And then you put here your function. In this case, I'm going to put sine of x squared, right? Sine of
Wouldn't
x.
that just be cosine of 9?
Hmm?
Wouldn't that just be cosine of 9? Yeah.
Sine of 9. What?
Porque
Oh,
remember
yes, sine
sine
of
and
9. That's correct.
cosine,
Yeah, it is.
3 squared is 9.
That's correct. So, but you press this one, enter, and then you have cosine of 9, control enter, and then you have the acceleration at the time 3 is negative. This acceleration in 3 is the negative 5.4668. Let me see if we have units. If we have units here, share screen. Right here. Okay. No, we don't have units, so it's just a number. Units over time square. Yeah. Okie dokie. Okay, now, total distance is the next question. Find the total distance traveled by the particle from time 0 to time 3. What to do?
The
Integral of who?
integral of the velocity of, I mean, the integral of the absolute value of the velocity.
Correct, sir.
at
Very
0 to
good. Very, very good. So just remember, this is the point. So it's from 0 to 3, x0 to x of 3. This is the formula you have to put on your paper. Then you know that this is x of 0 equals 5. Let me see. Yes, x0 equals 5. So you're going to put here and then you put this in the calculator, correct? It's important you put your equations, you put your procedure, because it's the way you're going to get all the points for this problem, okay? Whatever is missing, miss the
el
point.
absolute value.
Sí, cierto, el absolute value right here. Es el absolute value right here.
Ya nomás ponerlo en el calculator.
You put that in the calculator and you get the answer, okay? So as you see, all these problems are very similar. We are not really doing anything different. Velocity, position, acceleration. Usually you get the velocity, the graph of the velocity. In that way, they can ask you to do a derivative and they can ask you to do an integral, right? If they give you the position and you want the acceleration, you have to take two derivatives. If they give you the acceleration, you have to do two integrals to get the position. And that's annoying. So they put it at the middle and then one back and one forward, right? One derivative, one integral. Okay, let's see the next section. Let me see, share screen. Question 3. Find the position now of the particle at time t equals 3. So what is different now?
You have to find the actual integral.
The actual integral without absolute value, correct?
Yeah.
Very good.
And C is going to be 5.
Well, let's see. Yeah, x0 is the same one, right? So
Yeah.
we use just this one. It's the same integral except that you have no absolute values, right? You have no absolute values. It's the same equation. Just in the total distance, you put the absolute value. In this, the displacement of the position, you remove the absolute values. You see? It's pretty much the same. Mm-hmm. Okay, just the same, just remove zero value. And the last problem, the last question, stop share, let me see, share screen, this one, there is. So for the interval 0 to square root of 5 pi, find the time t at which the particle is the farthest to the right. Explain your answer. Possibly this is the most difficult part, correct? Because you have to find the maximum displacement. Remember that this particle right here in the graph, this is the area to the right, correct?
Yeah.
This is the area to the right. Then you have this to the left. Then you have this area is the amount of distance to the right, to the left, to the right. So at what moment you think you have the maximum displacement? Hmm? What is the reasoning?
¿Qué pasó, Ramírez?
It's very simple. Miren, this is the last question, right? This for this interval from 0 to square root of 5 pi, find the time at which the particle is farthest to the right, correct? Explain your answer. Remember that the displacement, the distance, right? This is the displacement, the maximum displacement is the area. So check the areas you have here below. How's this area respect this area? How's this area respect this one? How's this respect this one? How's this respect this one? How's that?
Déjame te digo esto, Ramírez.
Hmm?
El
Which one?
first area está más largo, más grande que todos los demás.
Correct.
Va a ser el area of the first area to the left.
Exactly. So this is the reasoning. If the area represents or gives the distance, the value of this area gives the distance of the displacement, this area is more than this one. So you subtract these two, correct? Then you get with some distance here, right? With some portion right here, because you subtract these two, this from this. Then this is less than this one, so you don't move all this one again, so you get short, correct? Then you subtract something, right? And then you add something less than you subtract. So Brandon is right. This is the maximum distance to the right, the maximum displacement, correct? At any other time, at the end of this and this and this, you are not that far to the right, correct? But that's nice. You can write that one, but how do you do this with numbers? Tienen una calculadora, you have a calculator. How do you explain this with numbers? Just explain me, just tell me what you do with the calculator. No lo hagan, don't do it. Just tell me, you have a calculator in the hand, you can use the calculator. How do you prove with numbers what you said?
Pues no se puede porque
Sí se puede.
No sabes el time.
Ah, a ver, Brandon, come on. Tú haces más cosas difíciles con los robots.
Ah, porque el time, ¿verdad?
Digo, si haces cosas más difíciles que esto. So, check this out. A ver. You have this function, correct? Let me just go to the calculator. It's important. So I put here a graph, right? And I put here sine of x squared. Let me just share the screen so you can see this. Correct? Okay, let me see. Stop share. Let me just share again. Here it is. Do you see now the calculator? Okay, let me just now menu, Windows Zoom, Windows settings. Let me just put the window. Let me just put here a negative a 0. Let me just put a 0 here at the left of x. And here, 0. Yes, and here I'm going to put control square root of 5 pi, exactly as I have in the problem, correct? Yeah. Then I want, let's see, let's just put the auto. Here I'm going to put -2, and here I'm going to put +2. So I'm going to see pretty much something like on the paper, correct? There is. Yep. Everybody see that? Okay, now, remember that you have to take the integral from here to get the thing. So let's see. So what I'm going to do is find the intersection. So menu, analyze, intersection, no intersection, escape.
0.
As the zeros, correct. Menu, analyze graph, the 0. So I put this one here. And I have this one. Let me just put this one at the side. And let me just use settings with more decimals, right? Okay, let me just find this one. So I menu, analyze graph, zeros, right here. So I have the second root. Let me just put it right here. Let me just put this one, menu, settings, cancel. Menu, analyze graph, 0. Now this one, I have this, right? 3.07. And then this, I know this is square root of 5 pi, this at the end, correct? So I'm going to put the last one, menu, analyze graph, 0, clean and clean. So here is, let me just take this one right here, correct? So you have all the times over there, correct? So if you take the integral from here, to this value, you get a number. Then you subtract the integral from here to here, correct? Or you take the integral from here to here and you get a value. Then you get the integral from here to here, and then you get a new value. Then you get the integral from here to here, and you get a different value, and so on. So every one of those numbers is less, correct? So this is what happens if you do this. Let me just put it here at the board. The integral from 0 to 1.7725 of b of t is greater than the integral from 0 to 2.5066 of b of t, greater than the integral from 0 to 3.07 of b of t, like this. Let me just show you. This is what I write in this one. This area is more than this area, is more than this area, is more than this one, and so on. So these are the displacements at the end of every time. So this displacement is more than this, than this, than this, and so on. Okay? That's the reasoning. Okay? If you get the numbers, you are going to see that. Everybody catch it? Yeah, not that bad, correct? Bueno. So remember, try to practice with more of these problems by your own. I know possibly you understand. No se confíen, right? Don't be confident. Try to practice the most possible. Okay, me falta Luis. Where is Luis? Okay. Well, let's move on to the next one. So now I want to do this. Let me see, what is it? Oops, let me see, right here. Okay, okay. So let me just share screen right here. Okay, let me just, okay, this one. Okay, did you see this screen? Fundamental theorem, correct? Fundamental theorem, yeah, is basically most of the problems free response you are going to find in an AP test, okay? More even than linear movement or area and volume. These that I call fundamental theorem and the other ones that I call integration differentiation are going to be the most, correct? So do you have these problems? You have this binder? Well, I have to give you the binder, Brandon.
Sí, ¿verdad?
Yeah, I have to give you the binder.
Yeah. Cuando diga Leo,
Pues sí.
pues creo que está trabajando otra vez, por eso digo.
Well, I don't know. Okay, you see this problem, so you see a function that is the graph of a function f. So it's two lines, a piecewise function, a line with the slope 3, yeah, and a slope -3, correct?
Ujú.
Okay, this is the graph of the function f shown above consists of two line segments. Let g be the function given by the integral of this function from 0 to x ft dt. This is very important. You see this portion right here. In the AP test, right here, you see this definition of a function through integral. They love to do that, okay? So they love to define functions as the integral of another function. This is the antiderivative of this, correct?
Mhm.
It's a specific antiderivative of this one. And then they want you ask, find functions, values of that function, correct?
Yeah.
So let me just put here the value here, g of x is the integral from 0 to x ft dt, right? So they love to do this. Stop share. So you see the board, this is the integral, the definition of this function as the integral of this one, right? And, right? Yeah, they want you find g of what? Let me see.
-1.
One?
Negative.
-1, correct. G of -1. So g of -1, g prime of -1, and g double prime in -1. So you have to find the value of the function g, the derivative in -1, and the second derivative in -1, correct? Now, what is the word you have to show? Well, this is very simple. If this is g of x, g of -1 is the integral from 0 to -1 of ft dt, correct? It's very important. Now, option 1, you get the function, let me just put this again.
At
You
negative.
get the equation of this line and you do the integral,
Yeah.
or you find the area using computing the area. You find the integral just computing the area under the line. So it's the area between 0 and 1. So it's the area of this triangle. So whatever is easier, right, for you, you do. So let me just put it right here, sketch it, right? This is -2, this is -1, this is 3, and so on. Okay. So let me just go back to the screen. So this is pretty much this function, right? So this integral, right, is the area right here, correct? But careful, what about these limits of integration? 0 to -1. What happened in this case?
You turn it to a negative?
Correct. These are upside down, so you have to put -1 through 0 ft dt. That's the correct display of the limits of integration. But when you flip the limits of integration, you have to put a negative in front of the integral, correct? Okay, now, you need the area between -1 and 0. Okay, this is 1, this is 3. What is that area?
Oh, that's
Base times height divided by 2.
1.5.
That is equals to
1.5.
1.5, correct? So this is going to be -1.5. Correct? Why negative? Because you have this negative at the front. Okay, you solve the first one. Now you have to solve the next one. So okay,
Well, that's just f of x.
g prime of x is the derivative respect x of 0 to x of ft dt. And this is f of x. Very good, Brandon. Now, if you want g prime of -1, you have to do f of -1. And that's equals to
0.
correct, 0. Yep. Now, you have to do g double prime of x. What is g double prime of x? Well, is f prime of x. Is the derivative. If g prime is fx, g double prime is f prime. So you have this one. So g double prime -1 is f prime of -1.
3.
That's correct. This is the slope of the tangent line. There is no tangent line here. Well, really, this is the tangent line by itself. So that's a 3. Okay? So you see there are no complex algebra, just concepts. This, and obviously the area, correct? Remember that you can do this analytically. So you can get this function and then do the integral by hand, but that is, you are spending time that is worth. So it's much better if you compute from the graph. It's faster. And it's going to be the same answer. Okay, questions at this point? Where is the fundamental theorem? Right here, correct? The derivative of the integral, they cancel out, you get this one, right? Another fundamental theorem really is this one, but it's the area under the line. And here, well, this is derivatives only, okay? Questions here? Everything fine? Clear?
How did you get g double prime of x to be 3?
Because it's the slope of the tangent line. So if this is rise over run, is 3 over 1, correct?
Because the slope of that line is 3x.
So the equation of this line is 3x, correct?
3x plus 3, ¿verdad?
Plus 3, correct. Sería así. What is the derivative? It's 3, correct? It's a constant, so no matter what is the point, the slope is the same, so it's 3. Okay? If they ask you the derivative in 1, so you have negative 3x plus 3, correct?
-3.
It's negative 3 because it's the slope of this line. What is the negative 3? Well, it's rise over run, correct? Catch it? Okay. Bueno. Let's go to the next question right here. Okay, so for what values of x in the open interval -2 to 2 is g increasing? Explain your reasoning. Oops.
Okay, so
G of x is increasing. This is the concept you have to handle. Yes. G of a is increasing at x equals c. Let me just put it. If g prime of c is positive, correct? Remember that that's the definition of increasing. If you have a function, let me just draw any function here, right? Something strange like this. Well, the function is increasing where the slope of the tangent lines is positive, correct?
I mean, let's go back to the thing.
To the problem?
Yeah.
Of course. Right here.
Yeah. Pues nomás
For
mira.
what values of x on the open interval -2 to 2 is g increasing? Explain your reasoning.
Well, isn't it easy? Like, can you just do it from the graph? From
You
negative
can.
to -1, it's decreasing. From -1 to 0, it's increasing. From 0 to 1, it's decreasing. And from 1 to 2, it's increasing.
A ver. Yeah. So let's see. Yeah, you can do that, but let me just, yeah. The explanation is exactly what I drew here, correct? So the function is increasing at a point if the derivative at that point is positive. That's correct. So then you translate exactly as you did. So g prime of x equals f of x, right? Now you catch the graphs. So remember the graphs. Much better. So the graph is pretty much like this. Yeah, positive, negative, right? So in 1. So f prime, f of x is positive where? F of x positive on what interval?
-1 to
Negative
1.
1 to 1. correct? Then g of x increasing on -1 to 1, correct? This is the reasoning. What you have to show to the reader? Your concept. This one right here. G of x is increasing at a point if the derivative at that point is positive. Then who's g prime? Then the graph. Then you determine where it is positive from the graph. You conclude.
Pero
It's not very difficult.
Ramirez, seguro que es así. Because isn't this like because doesn't have if the acceleration is negative but the velocity is positive, isn't that decreasing?
Bueno, vamos a ver. ¿Qué pasaría en ese caso? Let me just put a thing, right? So, you are thinking in velocity, that's correct. So, you are accelerating, correct? Then you stop. How's the graph? Like that, correct? When you stop, you reach the max, correct? Yeah. So the distance increases until you reach the max. Is when you stop, correct? You stop right here. So even here you accelerate, and then you here the acceleration is positive, and the other one is negative, correct? So it's pretty much the same here. You see here, right? This is what? You are taking this as the acceleration?
No, I'm taking that as the velocity.
This is the velocity?
Because you have to find g is increasing. So g is the distance or the displacement.
Yeah.
So that f of x is the velocity and f prime of x is the acceleration.
Anyway, in that case, fíjate bien, is here if this is the velocity here is negative, right? It's negative, but it's stopping, you see? Here it stops. So you're moving in this one, stops and accelerate, and then here you begin to stop, and then you go back, correct? You see that?
Sí, pero that means it's decreasing. Oh.
Correct.
Speed it's talking about itself.
Okay.
So
aquí la velocidad va incrementándose. Si esta es la velocidad, this is increasing, right? So the acceleration is increasing. So, mira, vamos a empezar aquí. You are moving to the left. Here you stop, and then you move here to the right, correct? So even in that situation, it's the same. But don't try to think beyond the scope of the problem in this case, correct? So you are not putting velocities or anything here. Don't try to ¿cómo te decirte? Be dispersed. So focus only in the concept. This is the concept. The function is increasing when the derivative is positive. This is the derivative. Then when this function is positive, that's increasing. That's it. Okay? Okay, next question. Let me share the screen right here. Z. For what values of x on the open interval -2, 2 is the graph of g concave down? Explain your reasoning.
That means it's
okay, concave down.
Decreasing.
Vamos a ver. Let me just put here a function that is concave up and concave down, right? Okay, let me just go to the screen right here to the board. So here the function is concave up, and here the function is concave down, correct? So here you have a max, here you have a mean, correct? So the concavity, right, is related with the mean or with the max, correct? And ends at the inflection point. Here are the inflection points, correct? At the moment you reach an inflection point, the concavity change. Now, the inflection point is where the second derivative is equal 0, correct?
Yeah.
Or possibly undefined. or undefined. Okay, so you catch this, then let's go back to the problem we have here. Yeah. So the second derivative
Is f prime of x.
is negative, right? Then this is concave what? When the second derivative is positive, then is concave what? Let me just
Negative is
right
concave up.
here. This is what? The second derivative is negative, is concave what? The second derivative is positive, or is concave what?
Concave up.
A ver, acuérdense. This is very important. Remember how the criteria for the second derivative to determine a max or a mean? You have a max, right? When the second derivative is what? Negative. You have a mean when the second derivative is positive, correct?
Oh,
So, entonces, what is the concavity?
when it's negative, it's concave up.
Correct. Es when it's
No, it's
negative,
concave.
no, concave
It's
down.
concave down. Yeah, concave down.
And es así. Correct. Bueno, entonces, in your problem, g double prime of x is f prime of x. And this is the slope of the line. Okay, so let's watch the graph again. Where do you have a mean or a max? Negative one or positive one?
Negative one.
In negative one, yes.
Porque
Yes.
G double prime of x is positive.
So you have a mean in negative one, correct?
Oh yeah, man.
And then you have a max in positive one. So mean at from negative to positive, right?
Let's see.
At x equals negative one, and you have a max at x equals one. Let me just put the board back. So you have this one, right? So you have a mean in negative one, and then you have a mean in positive one. So what is concave up?
Concave up is the mean.
Yeah, concave up is the mean. So that is going to be, let me see, fundamental theorem. I just find this fundamental theorem. So this is where it's concave down. So where you have a max. So it's in positive one, right? Aquí es concave up y aquí es concave down, correct? So it's between 0 and 2, correct? In 0 and 2. So it's clear the reasoning? Concave up, concave down, second derivative, right?
Yep.
Okay. Obviously, in 0, the derivative does not exist, correct? In 0 is undefined, it's a peak. So that is where the concavity changed, but it's not an inflection point, it's not a soft transition. Possibly the graph is broken, I don't know. Something happened. Or are two parabolas that connect on a peak. Okay, screen again. D, on the axis provided, sketch the graph of G on the closed interval -2, 2. Okay, so I don't see here the axis provided, but really what we have here is, if this is let me just put it right here. Let me just stop the screen, right? If this is the derivative, right? 2, -2, -1, 1, right? If this is the derivative, how could be the original function? Hmm? What do you think?
Nothing.
Hmm? Nothing?
Mm.
Well, you know you have what here. So at this point, right, you put these lines with dotted line here. And it's okay, well, let's see. Here, what have you here? Max or min in -1?
Gonna be a
We have a min, correct?
min.
So my function has to be something like this, correct? It's concave like this, correct?
I stone flexion point.
But remember that the inflection point is not soft. So this means that you have something here, a problem. So possibly you have here something like this. So something that move like this one, but you have to show here like some special transition, something strange, right? Not discontinuous, right? But something like this, right? Something like this or something like this. I don't know. Something like this, right? Mm-hmm. -1, so, or possibly less. I don't know. Let me see. Is 0. But obviously, these two concavities have to be there. So the only thing is join them here, right? It's not soft. It's just 3. A ver. Min is 3. And this is -3. Gosh, it's going to be a little bit difficult, right? So this is the mean, this is the max. So it's just the connection here, what we have to do. The connection. Has to be 3. It's going to be 3, 0, 3, and then here 3. Yeah, it's pretty much like this one, right? They are joined like that. Yeah. So it's pretty much the idea. Catch it? Remember, I'm using these two discovers I did, a min and a max, and I have to connect in some way over there. Okay. Questions here? This is no calculator allowed, you see? Right here is a no calculator. You don't need it really, right? Okay, a ver, questions before we move, or we stop right here to give you a break?
Yeah.
So it's clear this problem, pretty much. So for tomorrow, same time, we're going to be here. We are going to do exactly the same routine. We are going to do now the second problem. Again, you have a graph, there is a function, that is the integral of that graph, right? And then you have to discover g of 6, g prime of 6, g double prime, what interval is decreasing, where is concave down, and then we have to do a trapezoidal approximation. Well, that's going to be possibly the only extra, but these three are exactly solved in the way we solved this one, okay? If you want to go and practice with those three problems, pretty fine. Okay, really? No problem? Okay, so let me just